This is a velocity time graph. So the horizontal part of a velocity time graph is constant velocity. And we can just read it off the scale that it's doing 30 meters per second. In this first section, the velocity is increasing. It's gone from 0 up to 20. So that's acceleration. And acceleration, the definition of acceleration is the change in velocity over time. So in this section, the velocity's gone from 0 to 20, so that's a change of 20 in a time of 5 seconds. So the acceleration is 4 meters per second squared. This section is also accelerating, but this time the acceleration has gone from 20 to 30, so that's a change of 10 over a period of 5 seconds. So is 2 meters per second squared. On this other side, the velocity is decreasing, so we've got deceleration. Same way to work out the rate of deceleration. So in this first part, it's gone from 30 to 20, which is a change of 10, over a period of 10 seconds, so 1 meter per second squared. And in this last section, they've gone from 20 down to 0, which is a change of 20, in a time of 25 to 30, which is 5. So 4 meters per second. So matching the original initial acceleration, they've got the same gradient, but in opposite directions. The advantage of a velocity time graph is that it not only tells us the velocity and the acceleration, but it also shows us distance, because distance is the area. So in this first section, the area is a triangle. Area of a triangle is base times height divided by 2. So 5 times 20 over 2, which is 50 meters. Next shape is a trapezium. Area of a trapezium is the sum of the parallel sides, so 20 plus 30, divided by 2, times the height between them. 5 to 10 is a gap of 5. So that area is 20 plus 30 over 2, multiplied by 5, 125 meters. This middle section is a rectangle. Area of a rectangle is width times length, so 5 multiplied by 30, so 150 meters. Then we've got another trapezium. Area is sum of the parallel sides, so this side is 30, this side is 20 over 2, multiplied by the distance between them, which is 10, which gives us an answer of 250 meters. And then this last area is exactly the same as our first area, so is 50 meters again. We can translate this velocity time graph into a distance time graph. So in the first 5 seconds it travels 50 meters. So in our first 5 seconds it's going to travel 50 meters. In the next 5 seconds it's going to do another 125. So from here we're going to do another 125 meters. In the next 5 seconds, we're going to do another 150. So 50, 100, 150. Over the next 10 seconds, we're going to do 250. 50, 100, 150, 200, 250. And in the last 5 seconds, it's just going to do another 50 meters. Now when we connect these up, we've got a constant velocity between 10 and 15. So it's a straight line on a distance time graph between 10 and 15. The first section is acceleration, which means a concave curve. And in the last section, it's decelerating, which means a convex curve. So here we have a period of acceleration, a period of constant velocity, and a period of deceleration.